Okay. Hello everyone. My name is Arun. The title of my talk is The Era of Module Bundlers. Unfortunately, the mic is not working, so I'll have to scream for the next 30 minutes. A little something about me. My name is Arun, like I told you. I'm from New Delhi, India. I've been working in the software industry for the past 3 years, specializing in the web domain. I'm an open source enthusiast. I've contributed to several open source libraries and released some of my own libraries. Feel free to check out my open source work at github.com/ArunMichael or hit me up at Twitter. I'll tweet about this about the talk so we can access the slides from there. I work with this company called AdPushup. So AdPushup is an ad tech startup based out of New Delhi, India. So we help web publishers optimize their ad revenues through advanced A/B testing and layout optimization. So we have yet another tool for ad block monetization. It's called adrecover.com. So we are currently in the ad tech space working on ad tech solutions. So about the talk, the era of module bundlers. So I'll be talking about what JavaScript modules are in general, how and why do we bundle them, and sort of I'll cover the entire timeline on like how these tools around modules and module bundling have evolved over time. So like PPK mentioned, like modularization is the way to go, only if you do it the right way. So I'll be covering the optimization techniques required for it. So let's get started. By the way, all the demo code and the snippets will be available on this link. I'll share it on my Twitter handle after the talk. So firstly, there are two types of tools in the JavaScript ecosystem. So there are task runners and there are module bundlers. And sort of I'll cover like how are these two interrelated and how do they work together. So task runners are more like you define a configuration with your processes inside the configuration, and the task runner will execute those processes for you. So it can be as simple as creating a folder, minifying assets, deployment. And on the other hand, module bundlers are sort of tools which work entirely on JavaScript modules, and they are responsible for bundling your code and its dependencies together. So I'll be covering how these two things work together. So let's talk about JavaScript modules first. Yeah. So what is a module? A module is simply an abstraction layer that is created, that we create to sort of make our code more reusable. So obviously we do it for maintainability purposes. Your code has to be easier to read, easier to debug. Obviously, reusability purposes, like I told you. So the more modular the code is, better, easier it is to reuse it and test it out. So these are some of the things you might want to consider when modularizing your code. So module systems in JavaScript. Prior to ES6, there was no native module support in the language. So developers used to come up with their own sort of hacks and tips and tricks for sort of incorporating module system in JavaScript. But prior to ES6, there was no native support for modules. So I'll walk you guys through to some of the more prominent techniques that is used in the JavaScript ecosystem. So this is a very prominent approach. How many guys have seen this before? Yeah, so this is called immediately invoked function expression. Pretty straightforward. You have an anonymous function wrapped inside parentheses. Now this returns a function which we then execute. It's cool, like it's more like straightforward statement execution. As long as this module is present in your app, it will work fine. There is a variant of this very approach called, before that, how many people have used ES6? So yeah, so ES6 comes with this thing called block scoping. So prior to ES6, there was no such thing as block scoping in JavaScript. There was function scoping, of course, but now with ES6, you can do this, like just add two braces and you have a block right there. But obviously, with a block, const and let come into play. So you can check out this link. It's an article by Wes Boss. So he has explained a nice little way in which he sort of differentiates how immediately invoked functions expressions can be written in ES6 using the block scope structure. So it's pretty good. So this is another variant of the immediately invoked function expression method. So it's called object interface. It's like quite the same. It just exposes an API out to the object which you want to reuse in your code. So here we have an API with two methods, sum and product, which can be reused anytime you want it. More details on this can be found on this link. So mostly covering general design patterns on JavaScript. So again, this is a variant of the IIFE approach, the immediately invoked function expression. So these were more like not exactly module systems, but we can call them approaches which we use for sort of modularizing our code. So after that we have AMD and CommonJS. These are the module systems that were created, not like obviously not in the native, not as part of the native feature in the language. So these two module systems are like very much used to be very much common with now ES6 coming, ES6 modules coming right out. So I guess like I'm not pretty sure. Like let's see when these two things like fade away. So talking about AMD, AMD stands for asynchronous module definition. So AMD defines a specification where you have a define function in which you pass in the first, as a first parameter you pass the dependencies which you want to use in your application. So in this case I have a dependency called math and another called data. These are separate JavaScript files, by the way, which are written in AMD itself. So like AMD is able to figure out, okay, this is an AMD module, I need to add this, load this as a dependency. And by the way, these are loaded in the browser in non-blocking way. So it's not exactly, so it's asynchronous in nature. Once the dependencies are loaded, this callback function fires with the reference to that particular dependency available, so you can use it in your application then. Yes, the actual dependency, which here was math, has to be written in the AMD spec, so that AMD understands this is a particular AMD module that I have to load. So this is the way you write an AMD module. You have the define function again. You pass in a anonymous function where you have the API or whatever the functionality you want to add to the module. So again, like we have CommonJS. So CommonJS is it's pretty. How many people have written Node code before? This might this might look familiar. So it's more like, so CommonJS specifies a module.exports object, which defines the variable you want to export as a module. In this case, it's again the math module with the sum and product methods exposed as an API, and like using it is very, very easy. You just require it, and you have the method available for you in your application. So CommonJS was invented to be used in non-browser environments, so particularly servers and native environments. But with tools like Browserify and Webpack coming along, using CommonJS on the client side has become really easy. So we'll discuss about it more. So before that, module loaders. What are module loaders? So module loader is a tool which converts your modules written in a particular module format into browser understandable JavaScript, because like I told you, there was no support for modules in JavaScript natively. So whenever you write an AMD module or a CommonJS module, you need to run it through a module loader. Then only the browser will understand what the heck that is. So there's a very these two are like very commonly used module loaders for. For AMD we have require.js, for CommonJS and AMD we have system.js. You can check them out, pretty like straightforward to use. The thing to note about module loaders is that, so this is a very typical example taken from the require.js website itself. So here I'm requiring the actual require.js script and passing it a data main attribute, js/page1, which is a JavaScript file present in a JS folder. Now what this will do is this will fire up require and look for the entry point. So js/page1 is the entry point, and it will recursively look for page1.js dependencies and load them in the browser during runtime. So this works during runtime. I can show you an example as well. So this is a require.js demo. This is a, I hope it's visible. So this is a regular page with require.js on it, and it has a entry point called page1.js. So as you can see, require.js is loaded first. It looks for the entry point, which is page1.js. Now, if you look under the hood, require.js has a dependency called common. So it's like a file present in the same directory. So it looks for CommonJS and then loads it in the end. So that's how module loaders work during runtime. And on the other hand, module bundling works during your build time. So what happens is you have a module bundler, and you give it a bunch of modules, be it anything. It can be JavaScript, PNG, Sass, CSS, whatever. It will bundle all of it together into a single JavaScript bundle, which you can serve to the client. So again, this is done on this works during build time, not runtime. So how do module bundlers work? So they create a dependency graph, which is an abstract syntax tree. So basically, it looks for a module's dependencies and goes processes them recursively and plucks them out and injects it to the bundle. So you have index.js, for example, here. It has a dependency on API.js, model, and data. Once it figures out, index.js has a dependency on these three modules, it'll plug them out and add to the bundle. Similarly, it just follows along the dependency graph and creates the module, or creates the bundle. So like Browserify, like I told you, is one of the commonly used module bundlers. So the thing about Browserify is it doesn't only let you do require-based module inclusion in your client side. You can also use npm modules on the browser side, which is amazing. So it's totally blown away. So like using Browserify is pretty straightforward. You need to have npm installed. Just install Browserify globally if you want to use it globally, and give it the entry point of the file, and with the -o option, specify the bundle name which you want to produce. So Browserify will bundle up all of app.js dependencies and create the bundle for you. And this totally runs on the browser. Even though you've written CommonJS code, what Browserify will do is, during build time, it will pluck out all the CommonJS sort of abstractions that the browser requires to understand what CommonJS is, adds it to the bundle along with our application code, and serves to the client. So the browser is able to understand CommonJS code easily. So transforms. Browserify has this thing called transforms. So let's say you want to write ES6 for your current application, but obviously like browser support is not that good. It's like getting more better. But let's say you want to support older browsers as well. So you would want to use something called a transform. So like Browserify has this transform called Babelify. It's what it does is it converts ES6 code into ES5 code. So you can write your ES6 code, run Browserify with this Babelify option, and have your ES5 ready, and you can ship it to any browser you want. You can find a list of all of the Browserify transforms on this link. So using transforms is pretty straightforward. You use the Browserify command with the entry point of the application and give it a output bundle name. You specify a -t. This looks funky, but that's how it is. You specify the Babelify command with the preset of ES 2015. If you want to use ES 2015 or ES6, you need to have this preset installed along with Babelify. Now this is like really difficult if you want to do it on the command line. So that's why we have task runners. So task runners allow you to build a configuration of your entire bundling thing. So you can have a task for just bundling your JavaScript, a task for minifying it, perhaps a task for deploying it. So it looks something like this, like very common sort of bundle task runner configuration. You can have a task for watching files, for module bundling, for optimization or deployment, whatever. And it's pretty easy to use. So like there are like Grunt is really famous task runner. There is one more called Gulp, and like they're very simple to use, have an easy API, and have a like whole bunch of plugins you can use to build like almost any kind of build system you want. Now using this with Grunt, you would want the Grunt Browserify task. So this is the task name for Browserify. Obviously you need Bubblify and the preset. So once this is done, so this is what a Grunt file with a Browserify configuration looks like. So you have the entry point, which is app.js, and the bundle.js file, which will be generated after the bundling is complete. You specify the transform and whatever the preset you want to go with it. It's pretty straightforward. So this will create the bundle.js file with the CommonJS code, which you can use in any browser. Now let's talk about Webpack. Like Webpack is like the cool kid on the block these days, and I feel like it's about the ecosystem it offers and the sort of optimization techniques that it comes bundled with. So like you don't have to install like separate npm modules for optimization or like bundling your stuff. So it comes all within Webpack. In fact, if you're like going with Webpack, I don't think you need a task runner even. So again, like using and installing Webpack is pretty straightforward. You install it with the global flag. Usage is simple enough. You specify the entry point again and the bundle you want to bundle together. Again, like so Webpack works with AMD and CommonJS both module systems. So you can check out the documentation about how you can use it. It's pretty easy. So Webpack comes with a config file. So you have the option of creating a configuration file with which Webpack will understand. So it's by default called webpack.config.js. You can name it whatever you want and pass in the ---- config option to Webpack and point it to the file, which is the actual configuration file. So pretty simple. You have the entry point and you specify the output file name. You can also specify a bunch of other options like the folder name and the plugins you want to run through. We'll look at those plugins in a bit. So this graph shows the number of downloads Webpack has got over the last week. So it's like 1.5 million downloads. That's like a lot, and it clearly shows how developers are, using Webpack into their bundling optimization and sort of a build tool for their. Depends on what sort of apps they're building. Could be a React app, could be an Angular app. But the thing is that Webpack is really proved itself with these sort of pre-bundled optimization techniques that it comes with, and we'll discuss them. So Webpack has this thing called loaders and plugins. So just like we have transform in Browserify, we have these things called loaders with Webpack. So again, like loaders convert your one form of code into another. So you can use a Babel loader for converting ES6 to ES5, just like we had a Bubblify transform from Browserify. And plugins help you to act on the bundle itself. So if you're looking at optimization, if you're looking at say minification, for example, you would be using plugins. So these are two different types of things that Webpack depends on. So let's see how we can optimize a bundle with Webpack. So first and foremost is bundle analysis. You want to know what exactly is like there in your bundle. You want to know the exact the size of the modules you're using, the basically the contents. So there's this very cool NPM module for this called Webpack Bundle Analyzer. I'll show you a demo as well. So this is my Webpack configuration. I've installed the Webpack Bundle Analyzer using the npm command, npm install, whatever. And you just require it, have your Webpack configuration set up with your entry point and the bundle name. Here I'm using a simple loader for converting my ES5 into ES6, ES6 into ES5, sorry. And here at the bottom, I'm using a plugin, the plugin called this Bundle Analyzer plugin. So what this will do is this will build the entire bundle and pass it to this plugin, which then this plugin will analyze what are the contents of the bundle and how we can optimize it. So like again, it's pretty straightforward to use the So I just run Webpack. So by the way, if you have a webpack.config file already present in the folder in where you want to run Webpack, you can just do Webpack and it'll figure out. It'll automatically look for the webpack.config.js file and do the rest of the things. So it's currently building my bundle. So the bundle has been created, as you can see, and it has started a Webpack Bundle Analyzer process at this link. So by default, it's available on port 8888. So if you check it out, so this is the bundle analysis. So basically, we have the bundle.js, and you can see almost like 99% is node modules. So basically, I'm using almost 99% of the contents of my bundle is vendor code. So I have React DOM, and all these things related to React. Only this much portion is my actual app code. That's pretty sad. So this is a pretty neat tool. It's not visible. Let me. Yeah. So you can drill down to exact which module you want to look at, and you can simply see how much size it's taking, what's the path, and whether you really want to use it in your bundle or not. So this is a really cool plugin that you can use for your bundle analysis. There is another category of web-based analyzers that you can use. So I've included the link here. So these are entirely like web-based analyzers. You provide a stats file to the analyzer, and it'll show you a nice dependency graph, web-based entirely, and show you what all modules are present in your bundle. So this is how you create the stats file. You specify the profile/JSON option, and you give it a file where you want to write the stats to. So the stats basically contain information related to all of your module dependencies. So it'll contain what the size of the module, what the name is, what the type is, and this stats.json file is then given to the web-based analyzer. So I'll show you a sneak peek. Oh yeah, the net is not working. Sorry guys, but the internet is not working. Anyways, you give this stats.json object to upload your stats.json file to the web-based analyzer, and it'll give you sort of nice visualizations using which you can, figure out which modules you wanna check out from your bundle and which ones you really want. So once you're done with the analysis, there are built-in tools using which you can even further optimize your bundle. So in order to make it really production ready. So there's this uglification plugin built right into Webpack. It's called webpack.optimize.uglify.js, and it supports all of the options available for uglify.js. So you can just pass it into that function, and it will work fine. You just need to specify this one line, and you'll have a minified version of your bundle right away. Adding on top of it, you can use the node environment variable. This is again more of a custom plugin. So webpack.define plugin means that I'm creating a plugin right now. What this will do is it will look for the environment variable node env, and it'll look for this particular string production inside the bundle, and it'll figure out which parts of the bundle are required for this are required in the production code or not. So things like console.log statements, your unreachable code, all of those things get rejected from the bundle. So there's a quick shortcut to these two techniques. It's called the Webpack production flag. So whenever you're running Webpack, you can simply do Webpack space -p. This will basically perform these two steps in just this one single line of this one single command. So it will uglify the bundle as well as apply the node environment variable define plugin on top of it. So basically, this is like same as doing these two steps. Next, you have build time gzipping. We obviously know that our assets need to be minified and gzipped before sending them out to the client. But like, how do we do this? What is build time gzipping? We obviously know this. If you use to Express, you might be using the compression middleware. You simply install it, require it, and then simply use it as shown. It's pretty simple. Now, what this will do is it'll with every request going out from Express, it will simply compress the asset and serve it to the client. This works totally fine, but it comes at the cost of CPU and memory usage. So especially when you have an app where you're serving like assets like at every instant, this will not work. Instead, what you can do is you can do build time gzipping. So build time gzipping is simply creating a gzipped version of your bundle during build time, and then serving it out to the client instead of using a compression middleware in your application layer. So there's this plugin. This is a third-party plugin. It's not built into Webpack. So it's called Compression Webpack plugin. You simply install it and use it as here. So you simply install it, and you specify the path and the obviously the gzip extension. There are a bunch of other options you can specify. You can check out the documentation of the module. So what this will do is it will create the gzipped version of the bundle during build time. Now, when you're serving your JavaScript, the actual JavaScript file, you want to make sure that you've set the proper content encoding for your gzipped version. So say, so this is a very simple middleware. So it just looks for all the JavaScript files, creates the gzipped version of the JavaScript file, sets the proper content encoding, and then calls the next middleware in the middleware chain. So whenever you're serving gzipped version of your bundles, you want to make sure you set the proper encoding, and you can do this using this small snippet. Now, tree shaking. This is one of the very prominent features in Webpack. Well, it came out in Rollup. Rollup is also yet another bundle modular for JavaScript. So tree shaking involves dead code elimination, and it works with ES 2015 modules. And how does it eliminate dead code? We'll see. So this is a rather standard Webpack configuration I have here with the entry point and the output bundle specified. And I'm running a barbell loader for my ES6 code. Now, if you see my code, I have this math module which exposes, this is entirely written in ES6, so it exposes two methods, sum and product. But in app.js, I'm only using sum. I'm not using product. So what essentially should happen is in the bundle only the code for sum should be present and not product, because I'm not using it anyways. So once I do this, and if I run Webpack, so here I have the configuration. I'm running Webpack. So the bundle is created. Let's see what is inside the bundle. So this is the bundle that Webpack has created. So as you can see, even though I'm using just the sum method from my math module, it has included both sum as well as product in the actual bundle, which is not ideal, obviously. You would want only the parts which are required in the application to be part of your actual bundle. So tree shaking comes in handy here, but there's a catch. So like whenever we're using like I said, it only works with ES6 modules. So whenever you're using ES6 modules, we need this loader called barbell loader, and it has a dependency called barbell plugin blah 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 blah. And what this will do is this plugin will transform all your ES6 code into CommonJS code, and which is bad because like I said, ES 2015 modules can be tree shaken. So they have this thing called static structure, whereas CommonJS and others, they have dynamic structure and they cannot be tree shaken. So dynamic structure means the CommonJS and other module systems, their import and exports can change during runtime. And that's when Webpack fails. It doesn't understand what to include and what to exclude during runtime. So it will just add everything into the bundle. Whereas ES 2015 modules, we have a static structure where the import and exports don't change during runtime. So Webpack can clearly understand that this thing is required in the bundle, so I'll add it, and this is not required, I'll just discard it. So like I said, this is the catch. This particular module doesn't play very well with the Webpack configuration we have. But there's a workaround. It's the modules option. So you can specify this option in your barbell loader query options. So you can simply specify the preset and an option with it. It's called modules. So set it to false. It will stop converting your ES6 modules into CommonJS modules. So if we check that out. seems to be some issue with my configuration.
Does the presets have to be an array of arrays?
Sorry, what? The what?
In your presets.
So when you're specifying options with the preset, it has to be an array of array. Otherwise, if you have like if you want to use multiple presets like ES 2015, perhaps a preset for React, you can simply have an array of strings. So that'll work. I'm not sure why this is not working. Not working, not sure why. Okay. Anyways, there's seems to be some issue with my configuration. Yeah, so like I said, ES6 modules can be reshaken and CommonJS modules cannot. So you can check out the official Webpack documentation on how to actually have reshaken modules. So it's pretty straightforward and easy to use. Next, we'll discuss code splitting. So basically, code splitting divides your single bundle into different, a bunch of different modules which you can serve on demand. So basically, as and when a page requires a module, you can serve that module. So this is like entirely built into Webpack, so you can just use it right away. So for example, let's say we have a bundle.js and it has we can split it into 3 different parts. Let's say we have our styles in a separate file, our page1.js, the script related to our first page in a separate file, and similarly for the other file, page2.js. And we can load them on demand. So by that, what I mean is, let's say user accesses a route /page1. At that time, probably what we want to do is we only want to ship the styles file and the page1.js file. That's exactly what we can do with code splitting. Like there's a bunch of more examples, but this is like the common scenario where we would want to use code splitting, especially with single page applications. So let's talk about CSS code splitting. So you have your app code with the styles. So in order to make Webpack understand CSS, you need this thing called CSS loader. So like I said, like so Webpack understands only JavaScript, like plain JavaScript. It won't understand ES6, it won't understand CSS, it won't understand Sass or anything else. So for all of these file extensions, you need appropriate loaders. So there's a loader for CSS, there is a loader for Sass, Babel for ES6 and all that stuff. So so there's our app code with the styles. How does that look? I'll show you. So yeah, so this is a simple application I've built in ES6. So this is a React app. I'm simply importing my CSS into JavaScript. That looks kind of odd, but it works. So what Webpack will do is whenever it reaches this styles.css file as a dependency of this particular module, it will look for the specific module loader, which is going to be CSS loader. So you need CSS loader in order to make Webpack understand CSS. So once once Webpack figures out the CSS, it plucks it out and adds it to the bundle. The bundle serves it to the browser using a simple style tag, which is again added into the head section. After that, we have the style loader, which basically adds the CSS to your HTML DOM using the style tag. For that, you need the style loader. Then once you have the styles ready, you need to extract them away from the bundle and have a separate CSS file for it. For that, we use the extract text Webpack plugin. Pretty simple to use. You install it and specify the file name on which you want to save all the CSS styles to. So in this case, it goes to build/styles.css. Now you have a separate bundle for CSS, and rest of the JavaScript, in rest of your bundle, the CSS won't be included. So you can ship them separately. So you can split separate libraries as well. So in this case, we have a bundle with jQuery and Lodash as a dependency, along with the app code, of course. Now in this typical scenario, we would want to separate out the vendor code in a separate bundle, perhaps. So we could have a bundle.js for specifically for our app code, and perhaps a vendor.js for our vendor scripts, jQuery and Lodash. So you can code split libraries as well in using Webpack. So this is done using the CommonJS plugin. It's built into Webpack. You can use it straight away, specify the options you want to in order to create your chunks. So this is a handy thing. It's called implicit common vendor chunking. So basically, I use the CommonJS plugin. I specify the name of my bundle, and I pass a function to min chunks, which is an option in CommonJS plugin, where I tell it to include all of the libraries which are present in Node modules, which basically means I'll have all of the vendor code from Node modules into a separate file called vendor.js, which I can ship to the client. This is an important feature called automatic splitting. So this is the thing I was talking about. So like on-demand loading. So what is happening here is I have a simple web app. I've created a component for my header, a slider, and a product list. So I know above the fold, I know the header and the slider will be present. I need it, and I need it immediately. So what import header from this line is doing is importing it to the bundle, and it will make it available instantly. So as soon as the page loads, we have this header and the slider available. And what I'm doing here using the require.ensure syntax is I'm loading it asynchronously. So what this is doing is it picks up product list, the module product list, and then requires it inside the require.ensure call. What this will do is it'll load it separately apart from the upper mentioned components. The import header and slider will be, like I said, imported immediately, whereas the product list will be imported later on. And I can show you just one quick demo. Yeah, so here I have a simple web page with you can see two bundles getting loaded over here. So I'll show you the code first. So I have an index, so I've loaded index straight away, which is synchronous, and I'm loading my about.js asynchronously using the require.ensure function. What will happen is the actual bundle, which is the index bundle, will be loaded right away, and the next bundle will be loaded asynchronously using a separate script tag in the head. So this is automatically added by Webpack, and it is asynchronous. So it's no longer render blocking. So you can use it after your above the contents on the above the fold loads, and then you can use this. and it's completely non-render blocking. That's all I have, guys. Thank you so much.